Imagine an invisible threat. Hundreds of thousands of tons of nuclear waste accumulating across the planet, capable of contaminating groundwater and soil for countless generations. While much of the world continues to struggle with this daunting issue, China has stepped forward with a bold and visionary solution. Once a latecomer in the nuclear energy race, China now leads with over 70 reactors and hundreds of billions of dollars invested in advanced infrastructure. With the ambitious goal of transforming hazardous radioactive waste into a permanently safe resource, China has pioneered a breakthrough technology called vitrification, a process that promises to reshape the global approach to managing nuclear waste. Join Top 10 Discoveries Official as we dive into China's journey with vitrification, a stunning technological leap that's capturing the world's attention. Nuclear waste, the dangerous byproduct of nuclear energy, has become one of humanity's most pressing and persistent challenges. As of 2025, the world has accumulated over 275,000 tons of high-level nuclear waste, with an additional 11,000 tons being produced every year. This highly toxic waste can remain hazardous for tens of thousands of years, posing serious risks to both the environment and human health if not handled properly. One alarming example is the Hanford site in Washington State, USA. From 1943 to 1987, nuclear waste leaks from this facility contaminated over 200 square miles of groundwater, increasing cancer risks and tainting drinking water supplies. Despite the US government spending billions of dollars on cleanup, the problem remains far from resolved. So why is nuclear waste management so difficult? Traditional methods have shown severe limitations. Liquid waste stored in cooling pools is prone to leaks, as seen in the Fukushima disaster in 2011, which released millions of gallons of radioactive water into the environment. Dry casks, widely used in the US to store spent nuclear fuel, have a lifespan of just 40 to 50 years and are vulnerable to corrosion, requiring constant monitoring and costly replacement. Deep geological repositories, like the once promising Yucca Mountain project in Nevada, have been scrapped due to political disputes and projected costs in the tens of billions of dollars. While much of the world remains stuck in search of answers, China has stepped forward with a bold and ambitious strategy. Once a latecomer to nuclear energy in the 1980s, China has surged ahead at a remarkable pace. Today, the country operates 70 nuclear reactors and is building another 26. Its determination is evident in massive infrastructure investments, with billions of dollars pouring into advanced nuclear projects. While the US continues to rely on temporary solutions like dry casts and slow-paced research, China has pioneered a breakthrough technology that aims to solve the nuclear waste crisis permanently. This innovative approach is not only far safer, but also vastly more efficient, promising to reshape the global future of radioactive waste management. That solution is called vitrification. Vitrification, also known as the process of glassification, is revolutionizing how the world manages nuclear waste. This advanced technology transforms hazardous liquid radioactive waste into solid glass blocks that are safe, stable, and capable of lasting tens of thousands of years. Imagine dangerous substances like cesium-137, strontium-90, or plutonium, which can cause severe environmental contamination, being locked inside solid, leak-proof glass, immobilized forever. That's the promise of vitrification, and China is now turning that promise into reality. The vitrification process begins by mixing liquid nuclear waste, typically generated from reprocessing spent nuclear fuel, with a special type of glass material known as borosilicate glass. This mixture includes components such as silicon dioxide, aluminum oxide, and various metal oxides. The blended material is then heated in a furnace to extreme temperatures, around 2,200 degrees Fahrenheit, 1,200 degrees Celsius, until it melts into a homogeneous liquid. This molten substance is poured into stainless steel canisters, then cooled and solidified into durable glass logs that can safely contain radioactive waste for over 100,000 years. At the Guangyuan facility in Sichuan province, China currently produces about 60 vitrified canisters per year, with each canister weighing more than 880 pounds and holding waste that is now safely and stably stored. Compared to traditional nuclear waste storage methods, vitrification outperforms on nearly every front. Consider the dry casks widely used in the United States and other countries. These can only last 40 to 50 years, are prone to corrosion, and require regular maintenance and replacement at high cost. Cooling pools used for storing liquid waste are even riskier. They constantly need complex cooling systems, consume vast amounts of energy, and can leak radioactive material, as demonstrated by the Fukushima disaster in 2011. Deep geological repositories like Finland's Onkalo project are still under development, and others like the Yucca Mountain site in the US have been abandoned due to political and financial challenges. By contrast, vitrification offers unmatched safety and efficiency. The benefits of vitrification are undeniable. This method locks radioactive elements at the molecular level, preventing any leakage into the environment and protecting water sources from contamination. Additionally, vitrification can reduce the overall volume of nuclear waste by up to 50%, saving precious storage space compared to dry casks or liquid pools. Unlike water-cooled systems, vitrified waste requires no ongoing cooling infrastructure, significantly cutting down on long-term operational costs. Even more impressively, tests at the Guangyuan plant have shown that these glass blocks can withstand powerful earthquakes, up to magnitude 7 on the Richter scale, and can remain submerged in groundwater for over 1,000 years without leaking a trace of radiation. This is a major leap forward in nuclear waste safety and management. Vitrification isn't just a technical fix. It's the foundation for a more sustainable future for nuclear energy. By providing a safe and efficient solution to one of the industry's most dangerous byproducts, this technology helps minimize environmental risks and protect future generations from radioactive harm. While many countries, including the United States, still struggle with temporary solutions, China has taken the lead by implementing vitrification on a commercial scale, opening a new chapter in the global fight against nuclear waste. If vitrification represents a revolutionary leap in nuclear waste management, then China is the nation leading this revolution, driving innovation with cutting-edge advancements that push the technology to new heights. By adopting pioneering techniques like cold crucible induction melting, CCIM, and developing new materials, China has positioned itself at the forefront of the global nuclear energy industry, not just catching up to the West, but in many areas surpassing it. CCIM technology lies at the heart of China's breakthrough. Unlike traditional furnaces that rely on corrosion-prone refractory linings, CCIM uses electromagnetic induction to generate temperatures exceeding 2,200 degrees Fahrenheit or 1,200 degrees Celsius without any direct contact between the molten glass and the vessel walls. This design increases equipment lifespan by over 30% and significantly reduces maintenance costs. China has refined this technology to outperform even France's renowned ER7T7 vitrification furnace, long considered the global benchmark. At the Guangyuan facility in Sichuan province, CCIM has delivered 20% lower operational costs, while enabling the processing of larger waste volumes with greater precision and safety. This marks a turning point. China is no longer just learning from the West, it is setting new standards in nuclear technology. Equally impressive is China's integration of artificial intelligence and robotics at the Guangyuan plant. AI-powered robots handle the most hazardous steps of the vitrification process, from waste mixing to pouring molten glass into stainless steel canisters. This innovation has reduced the risk of radiation exposure to workers by 99%, ensuring an unprecedented level of workplace safety. The combination of CCIM and AI showcases China's ability to address complex engineering challenges through intelligent, high-efficiency solutions. Beyond CCIM, China is also pioneering the development of new vitrification materials. While most countries rely on borosilicate glass, China has successfully tested phosphate glass, which can contain 15% more radioactive waste than borosilicate. This breakthrough means fewer canisters are required, significantly reducing storage and transportation costs. Tests at Guangyuan have shown that phosphate glass logs can remain submerged in groundwater for over 1,000 years without leaking, even under extreme conditions. By contrast, France continues using borosilicate glass with 20% higher costs, and the US has yet to begin large-scale field testing of vitrification technologies. In this landscape, China is clearly redefining the technological baseline. This advancement is no accident. Between 2015 and 2025, China has invested over $2 billion into vitrification research and development, outpacing the US, where the Department of Energy's nuclear research budget was cut by 10% during the same period. The Guangyuan plant, capable of producing 60 vitrified canisters annually, each weighing over 880 pounds, stands as powerful evidence of China's ambition and technical capabilities. Vitrification is not merely a technical solution. It is a pivotal key to overcoming one of the most formidable barriers facing nuclear energy: public fear and uncertainty around nuclear waste. By transforming dangerous liquid waste into durable, stable glass, vitrification is ushering in a new era. One where nuclear energy is not only safer, but also more widely accepted. With its remarkable advancements in this field, China is now leading the charge, setting a pace that challenges traditional powerhouses like the United States and Europe to keep up. First and foremost, vitrification plays a critical role in protecting the environment. Disasters such as the Hanford site in the US, where more than 200 square miles of groundwater were contaminated, and the Fukushima meltdown in Japan, which released millions of gallons of radioactive water, have underscored the devastating consequences of inadequate waste management. Vitrification tackles this issue by immobilizing radioactive elements inside solid glass, preventing them from leaching into soil or groundwater. Tests show that these glass logs can endure harsh environmental conditions for over 100,000 years, offering long-term safety for generations to come. This level of durability simply cannot be matched by traditional methods like dry cast storage or liquid cooling pools. Second, vitrification helps build public trust and acceptance of nuclear power. For decades, fear of radioactive waste has slowed the expansion of nuclear energy, especially in countries like the US, where projects such as Yucca Mountain were abandoned due to community opposition. By offering a safe, long-lasting waste solution, vitrification addresses one of the most emotionally charged concerns surrounding nuclear energy. In contrast to the US, where progress is stalled, China is moving forward aggressively, using this technology to fast-track the construction of 26 new nuclear reactors. While many Western countries struggle to maintain aging infrastructure without sustainable waste management solutions. Even more importantly, vitrification is allowing China to shape global standards in nuclear waste handling. The Guangyuan plant alone processes over 52,800 gallons of liquid waste annually, and with a new, larger facility set to open in Gansu province by 2026. China is positioning itself not just as a user of the technology, but as a global benchmark setter. These facilities are laying the groundwork for new international best practices, driven by proven efficiency, safety, and scale. Lastly, vitrification provides a foundation for nuclear energy to become a vital part of clean energy strategies. One of the major criticisms of nuclear power has been the long-term waste issue. With that hurdle addressed, nuclear energy becomes a much more attractive alternative to fossil fuels like coal, which contribute massively to climate change and pollution. Nuclear power offers consistent, carbon-free electricity, and vitrification ensures that this power source doesn't come with long-term environmental risks. In this sense, vitrification is not just a technical solution, it's a powerful enabler of climate goals. With firm political will and billions of dollars in investment, China is turning this vision into reality. As the world grapples with energy transitions and climate challenges, vitrification may very well prove to be the technology that bridges the gap between clean energy ambitions and public safety concerns. And China is showing exactly how it can be done. China is not simply focused on solving its domestic nuclear waste crisis. It is pursuing a bold global vision to make nuclear energy a cornerstone of the world's clean energy future. At the heart of this strategy lies vitrification technology, which transforms dangerous nuclear waste into safe, solid glass. Through heavy infrastructure investment and strategic technology exports, China is positioning itself as the world's nuclear energy leader, pulling far ahead of the United States and its Western competitors. China's nuclear infrastructure is a clear reflection of this long-term vision. With over 70 nuclear reactors currently in operation and 26 more under construction, China has now surpassed the US, which operates only 93 reactors, most of which date back to the 1970s. The Chinese government has invested more than $100 billion in nuclear projects, from power generation to waste treatment facilities such as the Guangyuan vitrification plant in Sichuan province. These massive investments are not only boosting clean energy production, but are also helping to cut carbon emissions by 1.2 billion tons per year compared to coal, the most polluting energy source. In contrast, the United States generates just 19% of its electricity from nuclear, and progress is hampered by temporary waste management solutions and the lack of a cohesive long-term strategy. What sets China's vision apart is its ability to export vitrification technology globally. In 2024, China began deploying this technology at the Chashma nuclear power plant in Pakistan, helping the country safely manage its nuclear waste. Similar agreements are being negotiated with Argentina, signaling China's intent to establish vitrification as a global standard. Meanwhile, in the US, vitrification research at the Hanford site remains stuck in the pilot phase, far from commercial application. China, on the other hand, has already transformed vitrification into an exportable solution, solidifying its leadership in nuclear innovation. China's vision is further strengthened by a smart international collaboration strategy. Since 2018, China has studied cold crucible induction melting, CCIM technology from France. But it didn't stop there. Chinese engineers quickly enhanced the design, reducing operational costs and boosting performance. These improvements, paired with innovations like AI-powered automation and new materials such as phosphate glass, have enabled China to outpace even France, the original pioneer of vitrification. The combination of massive infrastructure investments, technological exports, and international cooperation has allowed China to emerge as a model for countries seeking effective nuclear waste solutions. By turning vision into action, China is not only addressing one of the most complex environmental challenges of our time, but also setting the stage for nuclear energy to play a defining role in the global clean energy transition. As the world races toward a carbon-free future, China is taking the lead with bold, visionary plans to reshape the nuclear energy landscape. While vitrification has already laid the foundation for safe nuclear waste management, China is preparing for a dramatic leap forward with thorium reactor technology, set to begin operations in Gansu province by 2026. This next-generation technology not only promises higher energy efficiency, but also significantly reduces nuclear waste, positioning China at the forefront of the clean energy revolution. The thorium reactor in Gansu represents a revolutionary step in nuclear innovation. Unlike conventional uranium-based reactors, thorium reactors produce radioactive waste with much shorter half-lives, measured in hundreds of years instead of tens of thousands. This means that vitrified glass logs storing this waste will only need shorter-term containment, reducing both the long-term risks and associated storage costs. Furthermore, thorium is far more abundant than uranium, allowing China to reduce its dependence on imported nuclear fuel. By integrating thorium reactors with vitrification, China is building a sustainable nuclear ecosystem, capable of delivering clean, stable electricity to millions of homes without putting pressure on the environment. This strategy not only addresses two of the biggest challenges in nuclear power, waste and fuel supply, but also offers a scalable model for long-term energy security. When compared to the United States, China is clearly pulling ahead in the technology race. In the US, NuScale powers small modular reactors, SMRs, a promising solution, are not expected to be operational until 2027, at least 2 years behind China's thorium timeline. While the US continues to rely on outdated uranium reactor technology and short-term fixes, China is doubling down on thorium and vitrification, to build a cleaner, more efficient nuclear future. Early testing at the Gansu thorium site reveals that these new reactors can reduce nuclear waste by up to 30% compared to uranium reactors, a game-changing figure when paired with China's advanced vitrification technology. Together, these innovations dramatically lower the environmental and logistical burdens of nuclear power. But the significance of these developments goes far beyond China's borders. With the thorium reactor project, China is pioneering a technology that could define the next generation of nuclear power plants. If successful, this model could be replicated worldwide, from Asia to Africa, helping countries reduce carbon emissions and address the global energy crisis with a reliable, low-emission solution. Vitrification, transforming radioactive waste into solid, secure glass, and the upcoming thorium reactor in Gansu stand as clear testaments to China's far-reaching strategic vision. With over $100 billion invested in infrastructure, the export of nuclear technology to Pakistan and Argentina, and a plan to cut 1.2 billion tons of CO2 emissions each year, China is not only addressing the nuclear waste crisis, it's shaping a new era of clean energy. While the United States continues to rely on short-term stopgaps, China has laid the foundation for a carbon-free future, a future where nuclear energy becomes a reliable and sustainable pillar of global power systems. This isn't just a technical victory. It's a powerful demonstration of what long-term strategy can achieve in a world defined by rapid change. As the race between nations to save the planet intensifies, we're left with some powerful questions. Will vitrification become the key that lets China rewrite humanity's energy future? Is this breakthrough just the surface of a deeper, more ambitious plan that China has yet to reveal? And how will the US and other major powers respond in this high-stakes energy race? Tell us what you think in the comments below. Don't forget to hit subscribe so you never miss our latest insights into technology, global strategy, and the inventions that are reshaping our world. This is Top 10 Discoveries Official, and we'll be back soon with untold stories, boundary-breaking breakthroughs, and quiet revolutions with global impact. Thanks for watching, and we'll see you in the next video.